Alright, we now look at perfect substitutes and perfect complements. So, first, perfect substitutes. So, perfect substitutes are cases where the consumer is willing to substitute one good for other at a constant rate. Okay. So, as an example, consider two commodities, Aquafina bottles, which is represented up as A, and Bisleri bottles, which are represented as B. So both Aquafina and Bisleri bottles are available in 1 liter packages. So you are only interested in the total amount of water that you have. So let's say your utility is just the total amount of water, then the total amount of water that you have is 1 into A plus 1 into B. That is nothing but A plus B. Okay. Now, irrespective of how much A and how much B you have, you are always willing to substitute 1 unit of Aquafina bottle for 1 unit of Bisleri bottle. So irrespective of wherever you are, if somebody comes and he's exchanging one Aquafina bottle for one Bisleri bottle, you will do that exchange. You don't mind doing that exchange. It won't make you better off. That is, it won't increase your utility, but it won't decrease your utility either. So that's the whole idea here. Now, if I want to plot this the indifference curves for this utility function, let's say this is your A and this is your B. Okay. Now the way to plot ICs is you pick different U values. So let's say you want to plot the IC corresponding to utility level 4. So you have A plus B is equals to 4. Now this is the equation of a line. If you want to plot the equation of a line, the simple case is first you assume x coordinate to be 0. So you get 0 plus b is equals to 4 implies b is equals to 4. So a 0, b 4. So this is that point 0 comma 4. The second part would be when you assume b to be 0. So you take a plus 0 is equals to 4 implies a is equals to 4. So the point becomes 4 comma 0. Okay. Now when you connect these 2 points, you get your IC corresponding to utility level of 4. Similarly, if you want to plot utility level 6 line, it would be this 6 comma 0 and 0 comma 6, and similarly utility level 8 line 8 comma 0 and 0 comma 8. Okay. So I recommend you to revise some chapter on lines. Okay, you can go online and search for anything about straight lines. Do a basic revision of straight lines because that is absolutely important. So at this point, if you have any problem in straight lines, pause this video, go online on YouTube, or you can get hold of any textbook from 11th or 12th standard and look up straight lines. So this is something you're supposed to know from this point onwards. Okay. All right. So moving forward, let's say now uh, Aquafina is available only in half-liter bottles, and Bisleri is still available in 1 liter bottles. Now the total amount of water that you have would be half into A plus 1 into B, which is A by 2 plus B. Okay. Now another way to write the same utility function would be V is equals to twice U. As we saw, multiplying by a positive number does not change anything. It's a positive monotonic transformation, and that's why 2U can also be a representative utility function. So 2U becomes A plus 2B. Okay, so V is equals to A plus 2B. Now this thing, uh, you can say it is the amount of half liter. If half liter were your units, so this is the amount of half liters that you have. So A by 2 plus B was the amount of liters that you have. A plus 2B is the amount of half liters that you have. So it's you can have that kind of interpretation. A lot of times, not all utility functions will have some economic interpretation. The important thing to understand is that you need to be able to solve anything irrespective of what the interpretation is. Okay, so you need to be able to solve these things. Now, coming back to how to plot this thing. So let's say now you have, this is your A, this is your B. Suppose you want to plot utility level of 4. So let's say, coming back to this utility function, you have A by 2 plus B is equals to 4. Okay. Now keeping A equals to 0, you get B equals to 4. Keeping B equals to 0, you get A by 2 is equals to 4 or A equals to 8. So this point becomes 8 comma 0 and this point becomes 0 comma 4. So the indifference curves now look like this. So they'll be flatter than the initial indifference curves. So these curves had a slope of 1. These curves would have a slope of 1 by 2. Okay, so I'm hoping by this time you have revised straight lines and you have looked at what it means for something to have slope half or something to have slope 1. So I'm not going into that. So this is how your lines are going to be. The flatter lines have a smaller slope. Now technically the slope is -1. Okay, so if you have a downward sloping line, the slope is negative. The negative comes from the fact that it is downward sloping, and this is also downward sloping line, so the slope is -1/2. Had the line been something like this, its slope would have been some positive number. Okay, so this is an upward sloping line, these are all downward sloping lines. Now we already saw that indifference curves are downward sloping, so that's why the negative here is nothing surprising, and that's why a lot of times in economics I will be skipping this negative part, but you would just assume that whenever the slope is downward sloping, then negative is there. Okay, so that's your indifference curves for perfect substitutes. Okay, now uh, now let's look at perfect complements. So perfect complements basically represent goods which you like to consume as complements. For example, left leg shoes and right leg shoes. So these are complements. You want them in pairs. You cannot have just the left leg shoe or just the right leg shoe. So the amount of actual pairs that you have is the minima of this thing. So we can write that utility is equals to minima of left leg shoe and right leg shoe. Now the question is how do we plot such a function? Okay. So let me say left leg shoe is simply x and right leg shoe is simply y. So this is minima of x comma y. Now how does the min function work? This is known as the minima function or Leontief function or the min function. So how does this function work? So you input two things in it, and whatever is the minimum of the two things, it will report that thing as the output. For example, if the input is 3 comma 4, it will give the input as 3. If the input is 7 comma 1, it will give the output as 1. If the input is 3 comma 3, since both the numbers are equal, it can pick any of these things. Okay, so whatever is the minima of the two numbers, that is the one the output will be given by the min function. Okay, now how to plot the min function? Okay, so these are all xy coordinates. These are all x and y values. This is your x-axis, this is your y-axis. You pick any point x comma y here. Okay, now if this x coordinate is less than y coordinate, the reported value would be x. Okay, so let me take this as case 1. If x is less than y, then min function reports x, that is utility is equals to x. Okay, if on the other hand you have x greater than y, then main function would report y, that is utility equals to y. And the third case is if x is equals to y, then min function would report either. Okay, so you can take any case, either u equals to y or u equals to x, anything is feasible. So the first step to solving the main function kind of problems is you plot the x equals to y cases. So you select those cases where the you either of these two things are equal, and the u function can report any of those things. So let me just remove this from here for now. So this is my x equals to y line. Any arbitrary point here would have its x coordinate equal to y coordinate. Okay. Now if I talk about points to the right of this line, and I take any point here, this point is to the right of my random point which had x equals to y. So if I move to right, I am increasing my x, keeping my y constant. So this point would have your x greater than y. Now x greater than y is the second case in which main function reports u equals to y. Okay. On the other hand, if I move to the left, so I'll be basically in this zone. Now in this zone you have, if you're in this zone, you're, let's say, at a point like this which is to the left of x equals to y. So you have x less than y. Now if x is less than y, the main function reports u equals to x. Okay. So here's what we need to do. First you need to identify the points which divide my plane, the entire consumption set. So these are the points where the both parts of the main function are equivalent, and then you basically along this border you can divide the entire consumption set into two regions, one where utility function behaves in one manner, another where utility function behaves in another manner. So these are your two zones, so to say. Okay, now keep this figure in mind. I prefer if you could basically draw it in your notebook or somewhere. Okay, everything which proceeds from this would require a lot of graph drawing, so I hope you have your notebooks ready, and feel free to pause this video whenever you have any problem and go back and try to understand it again. So now let's again look at this graph. This is your x equals to y, this is x greater than y, which means u equals to y, this is x less than y, which implies u equals to x. Now u equals to y. So in this entire right region you have utility function equal to y. Okay, so let's say I want to plot the utility level equals to 4 indifference curve. This implies I would have y equals to 4 line corresponding to utility equals to 4. So all the points where the y coordinate is 4 would be corresponding to my indifference curve for utility level 4. Okay, so my y equals to 4 line is basically this line. This is your y equals to 4, which has different points on it, like 0, 4, 1, 4, 2, 4, 3, 4, 4, 4. The 4, 4 point will lie here because this line has all the points which is x equals to y format. On the right of it would have 5, 4, 6, 4, 7, 4, and so on. So this is your IC. This is the IC that you're looking for. So let me just put this in bold. Okay. On the left hand side you have utility equals to, on the left hand side you have utility equals to x. So let's say you want to plot utility equals to 4 line here. I see here would mean x equals to 4. So let me draw the x equals to 4 line. It would now be a line like this, and so on. Okay. So this is your 4 comma 0, 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 4, and then you have this solid line, because the utility function behaves like this only in this region. Okay, so it behaves like this only in this region. So this is your utility equals to 4 indifference curve. So you'll have different indifference curves, utility 6, utility 8, 9, 9.5, and so on. So you'll have L-shaped curves which are bent along this x equals to y line. You'll have ICs here. So your min function, basically your perfect complements for indifferent preferences, will have L-shaped indifference curves. Okay. Now let's take another example. So this was a simple case where you had x equal to y. You are substituting, complementing one unit of x with one unit of y. Now let's take an example. So suppose you like your tea with 1 part milk and 2 parts water. So you want to mix 1 part milk with 2 parts water. Okay, that is, you like more of water and less of milk. So now you're basically complementing milk and water together. Okay, so I want to find out what the utility function would look like. A very rookie mistake, a very common mistake that I've seen a lot of students do is they directly write utility equals to min of, let's say this is x and this is y. So people write just min of x comma 2y. Now this is wrong. Okay, so try to imagine that you want to measure the amount of tea that you have. Okay, so if you have x units of milk, okay, you have enough milk for x by 1 cups of tea, because you, for each cup tea you need 1 part milk. So if you have x parts of milk, you can get x by 1 cups of tea. And if you have y parts of water, since you need 2 parts water for each cup of tea, you have enough water for y by 2 cups of tea. And the minimum of these two things will basically give you how much of tea you can make. Alright, so if you have, let's say, 5 parts of milk and 7 parts of water, okay, then you have enough milk for 5 cups of tea, but you have enough water only for 3.5 cups of tea, because you need 2 parts of water for each cup of tea. So you're actually looking, if you had been using this utility function, the answer would have been 5. But actually the answer is minimum of these two things, which is 3.5, which now you see is obvious, because it is not milk which is is the limiting part. It is water which is the limiting part here. So even though you have more of water, you require more of water, and that's why even though water is more, it is still limiting in this case. Okay. So how do I plot this? So once I reach this point, once I reach utility equals to x comma y by 2, you can do a monotonic transformation and multiply the entire thing by 2 and write v is equals to min of 2x comma y. Okay, you can work with either of these two things. So as I show, the results do not change whatever I do. Okay, so I'll plot both these things here. So utility equals to x comma y by 2. The first part that you have to do is x equals to y by 2. Okay, x equals to y by 2, which is y equals to 2x, would be a line with slope plus 2. Okay, so it would be a line which is steeper, slightly steeper like this. Okay. And now let's say you want to plot utility. So here you have your x equals to y by 2. So on the right side you would have x greater than y by 2. So utility would be the minimum of these two things, which is y by 2. On the left hand side you would have x less than y by 2. So utility equals to x. Now here you have utility equals to x, so you would have vertical lines. Here you have utility equals to y by 2, so you will have horizontal lines. So okay, so let's say you have utility equals to 4 in difference curve. It will pass through all points corresponding to y by 2 equals to 4, which is basically y by 2 equals to 8. So you will have points where you have y equals to 8. On the other hand, you will have points here which are corresponding to x equals to 4, because you have utility equals to 4. And this point would basically be 4, 8, which does lie on x equals to y by 2 line. Okay, so this is your utility level 4 IC. Now let me come here, which is your v equals to min of, sorry, I forgot to write the mins here. The mins have to be written. So min of 2x comma y. So the dividing line is 2x equals to y, which is the same as before. Y equals to x by 2 is same as 2x equals to y. So again you will have a slope 2 line, 2x equals to y. Okay. Now v was obtained by taking twice of utility. So whichever point had utility 4 would now have v value equal to 8. So I need to plot the v equals to 8 line and check that it is same as the u equals to 4 line. Okay. So here's what I need to do. 2x equals to y. So this part is your 2x greater than y. So utility equals to y. This part is 2x less than y. So utility equals to 2x. Now utility equals to y, sorry, I should be writing v equals to 2x and v equals to y, because the function I am looking at right now is v. Okay. So v equals to 8 will correspond to all those points where y is equals to 8. So this would be your y equals to 8 line, which is the same as earlier. Okay. Now I am plotting v equals to 8 instead of u, and 2x equals to 8 implies x equals to 4. So this is your x equals to 4 line, which is again same as earlier, and this point again would be 4 comma 8. Okay, so the ICs are going to be same. It's just that the name of the ICs are going to be different. So initially you had this IC which was corresponding to utility U level of let's say 8. Now you have corresponding IC for V equals to 16. This was U equals to 12. This is now V equals to 24, and this was U equals to 16. Now you have V equals to 32. So that's going to be your perfect complements for min of x comma y by 2 or min of 2x comma y. At this point I want you to try these problems, the examples. You have to find the ICs for each of these cases. So begin with the basic idea. Let's say you have this particular function in mind. So first look at the left part, then look at the right part. Okay, so first find the points on the Cartesian plane where these two parts are going to be equal. Basically when x plus 2y is equal to 2x plus y, and that should give you the dividing line. One part will behave as left part, one part will behave as the right part, and basically you can see which part is which by comparing the values. Okay. So following this, in the video itself I'll be talking about all these 12 questions and their solutions. So I'll recommend that you solve each part one by one, and then you look at the solution corresponding to it. Okay. So let's start now. The first thing is min of x plus 2y comma 2x plus y. So the first thing is I want to find the points where these two things are equal. So x plus 2y is equal to 2x plus y implies I can cancel the common things and simply get x equals to y. So the dividing line is still x equals to y line. Okay. Now the min function will report x plus 2y if x plus 2y is less than 2x plus y. When I cancel the common parts, I get when y is less than x. So y less than x would mean utility function is x plus 2y. Now y less than x happens on the right side. So we saw this, that the right side corresponds to x greater than y or y less than x. This would imply utility equals to x plus 2y. Okay. Logically, the opposite side of this line should correspond to the other part, but we'll just look at it here. So the utility function will report this thing if 2x plus y is less than x plus 2y, which implies when x is less than y, which we know happens when you are moved to the left. So this is the point where you have x less than y, which implies utility equals to 2x plus y. Okay. Now x plus 2y. Okay, let's look at x plus 2y. Suppose you want to plot utility level of 4. Okay. Then you're basically looking at the line x plus 2y is equal to 4. Okay. So when you're talking about this line, whatever it is, it occurs only in the right portion of the x equals to y line. Okay. It does not happen on the left side, because on the left side the utility function is different. So on the right portion you need it to behave as x plus 2y. So x plus 2y is equals to 4. Now from your basics about lines, you might know that this thing has some slope. So to find out the slope, what I can do is I can write this as in the y equals to mx plus c format. So whatever line you have, when you break it down into y equals to mx plus c format, the m becomes your slope. Okay. So when I have this line, I can reconstruct this as 2y is equals to minus 1x plus 4. This implies y is equals to minus 1 by 2 x plus 4. So this would be a slope minus half line. Alright, so it would be a slightly flatter than the 45-degree line, so it would be a line like, let's say this. Okay. And it should pass through this point. So this point is the x-intercept when you make y equals to 0. So x equals to 4. So this is a point here, 4 comma 0. And there will be a point here. If you want to find this point, what you have to do is this point is the intersection of this line and the x equals to y line. So if you want to solve this point, you can simply write these two equations, x plus 2y is equals to 4, x equals to y, and when you solve this, you get x equals to y is equals to 4 by 3. Okay, so that's your point 4 by 3 comma 4 by 3. Now let's look at the left region where the utility function is 2x plus y. So talking about the left region, if I want to plot utility equals to 4 indifference curve, the equation becomes 2x plus y is equals to 4. Again, I can rearrange this to write y equals to minus 2x plus 4. So the slope becomes minus 2. So this is going to be steeper. Okay, so it's going to be a steeper line. So it will start from here somewhere. Okay, the point is going to be, the point here is the y coordinate. So it is simply going to be, when you make this x 0, you get y equals to 4. So this point is going to be 0 comma 4. And the point where it intersects the x equals to y line. So if you want to solve that point, you write these things together. 2x plus y is equals to 4 and x equals to y. Now when I solve these things simultaneously, I get x equals to y equals to 4 by 3, which is again this point. So these are going to be our ICs, steeper here, flatter here, steeper here, flatter here, steeper here, flatter here. Now it's not at all surprising that the two arms of this indifference curve, they meet. Okay, so this point is the same point. Here in this case we have this point as 4 by 3 comma 4 by 3. It is not at all surprising because your indifference curves have to be continuous. Okay, so indifference curves are continuous because in this point, at this point x equals to y, the function can behave as either of these two parts. So either of the parts must give me the same information. So if this is giving me information 4, this is also giving me information 4, and that's why both these things for utility level 4 must meet at a common point. And that's a common point. Okay, so this is how you're basically going to do such questions. First you are going to solve point, the line which divides these two things, which is your x equals to y line, and then about these line you are going to find your two zones where utility function behaves as different things, and then finally about these two zones you are going to find the ICs. So you are going to draw the IC here, you are going to draw the IC here, and then you have the basic structure of the entire ICs. So let's look at the next problem now. Min of x comma 2y plus min of 2x comma y. So utility equals to min of x comma 2y plus min of 2x comma y. So you have two things happening here, min of x and 2y. So the first part of your utility reports the min of these two things. The second part reports these two things. So you can imagine this as function 1 and function 2. So your utility is basically f1 plus f2. So what we'll do is we'll first plot f1, then we'll plot f2, and then we'll add the two things up. Okay. So for f1 you have min of, for f1 you have min of x comma 2y. Now the two things are equal when x is equals to 2y. Okay, so x equals to 2y is your y equals to x by 2 line, which is the slope half line. So this is your x equals to 2y line. On the right side of this you have x greater than 2y, so f1 will be 2y. On the left side you have x less than 2y, which means f1 will be equal to x. Okay, so that part is clear. Now let's look at the other part. The other part is min of 2x comma y. The dividing line would be 2x equals to y, that is the slope 2 line. So let me just plot this here. 2x equals to y. On the left side you would have 2x less than y, so f2 would be equal to 2x. Similarly, on the right hand side, you would have f2 to be equal to y. Okay. Now f1 is equals to x to the entire left of this zone. So now I have three zones basically. I have this zone 1, zone 2 and zone 3. Okay. In zone 1, f1 behaves as x. Okay. I should better write this with red. So in zone 1, you have f1 equals to x and f2 is equals to 2x. In zone 2, f2 is equals to y, f1 equals to x. Okay. And in zone 3, f1 is equals to 2y and f2 is also equals to y, because f2 is equals to y to the entire right of this green line. So now you have your f1 and f2 in all the three regions, so you can write down your utility function. Utility equals to just f1 plus f2, so it is 3x. Utility equals to x plus y, and utility equals to 3y. Now that that part is sorted out, I'll just draw a larger thing. This is your x equals y equals to 2x, this is y equals to x by 2. Here you have utility equals to 3x, here you have utility equals to x plus y, here you have utility equals to 3y. So here the slope is 3, here the slope is 1. If you write down this as y equals to mx plus c format, you'll see slope 1 or minus 1. Like I said, I'm going to assume that you know the slopes are going to be negative a lot of times. Sorry. I committed a mistake. Just forget this. Here the slope is going to be 1. Okay. Here this y equals to u equals to 3x. So u equals to 3x means that all the points which have the same x coordinate will have the same utility level. So x coordinate same means a vertical line. So all these points have same x coordinate, so they will all be having the same utility level. Here the utility would be slope 1, and here the utility would be along y coordinate. So all the points which have the same y coordinate would have the same utility. Okay. So this is what your indifference curves will look like. Right, so that's your indifference curves, which obviously looks slightly different from whatever we have done till now. Now let's look at the third part, that is min of x square comma y. So again the starting idea would remain the same. So you have u equals to min of x square comma y. So the first thing that you do is you plot the points where the two parts are same. So x square equals to y. So y equals to x square is a curve like this. It's no longer a straight line, it's a curve. So you can look at the curve of y equals to x square on Google or anywhere else, or you can wait for till you do the part about calculus and do the problem set on curve plotting. Anyway, so this is your y equals to x square curve. Now here you have x square greater than y, so it means u equals to y. On this part you have x square less than y, so you have utility equals to x square. Now utility being equal to x square means that it is only dependent on x coordinate. So all the points which have the same x coordinate will have the same utility. So if you have different points, like let's say this is a point 1 comma 1, let's say this is the point 1 comma 1, this is the point 1 comma 2, 1 comma 3, 1 comma 4. So all these points will have the same utility because the x square is same on all these points. So the IC is going to be vertical here. And these points, let's say they are 2 comma 1, 2, 3 comma 1, 4 comma 1, 5 comma 1. All these points have the same y coordinate, so they are going to be on the same IC. So your ICs are again going to be L-shaped, but the points, the corner points are going to lie along the curve y equals to x square now and not along a line. So that's the only difference that you have in x square comma y. Okay, so do not worry about the economic interpretation of this. Okay, that is not of consequence here. The main thing is that it's going to be a mathematical thing that you have to solve. So in a lot of these questions, you might not be able to get what is happening economically. What does it mean? What this person is doing? Minimize x comma 2y plus minimize 2x comma y. But the whole game is that it's not important what the economic interpretation is as long as you're able to solve it. Okay, so the examiner is going to test your maths and your math solving ability, and he's not going to be interested in if you can make an economic interpretation out of it or not. Let's look at the next part, max of x comma y. So max of x comma y, you can think of it as this the, the opposite of min function. Min function reports the minimum of two values. Max function reports the maximum of two values. Okay, so max of x comma y. So an economic interpretation could be that you are getting different packages from different companies. So there are different companies which are recruiting you. X is the package from one company, Y is the package from other firm. So obviously you cannot take up both the jobs. Your final utility would be maximum whatever these two things are, these two companies are offering to you. Okay, so your utility function in the max case. Again, I'll do the same thing here. First, I'll do the x equals to y zone. So the two parts being equal is your x equals to y. Okay. Now, max function reports x if x is greater than y. So as we've already seen, this is the zone for x greater than y. So here max function reports x, which implies utility equals to x. Okay. And on the left hand side, you'll have the opposite case. So max function reports y if y is greater than x, and then utility function simply becomes y. So you will have x less than y here, which implies utility equals to y. So all the points with the same y coordinate will have the same utility level here. So same y coordinate means a horizontal line. So your line would look like this, a horizontal line. This, and here you have all the points with the same x coordinate on the same utility level. So same x coordinate means a vertical line. So your ICs are going to look like this. On the other hand, we talked about the min function. In the min function, you have u min equals to y on this side and u min equals to x on this side, because the min function was reporting the smaller of the two values. So that's why we got all the y coordinates same, means the min function was like this. So the green lines report the ICs of the main function, the red line reports the ICs of the max function. So the min function is going to be kind of upward, opening upwards, and max function is going to be opening downwards. So this is a crucial difference. So in the rest of the things, I want you to proceed by similar manner. Some of them get a little complicated, but that's the challenging part. And then you can basically look at the solutions, the link for which I'll be providing, and then you can go through it.